Hello everyone, welcome to Learn Python in 10 minutes. I am Sabyasachi, faculty at Pixeltests. So we are learning Python as it's used in many fields and industries: engineering, web development, AI, machine learning, data science, and more. So once you learn the fundamentals, you can grow into the job of your choice with massive salaries. Python is the first step. So let's begin. Now you can see today's Python, we are going to learn the topics which are hello world, strings, variables, arithmetic, and comments, right? To do that, what we are going to do is we are going to use Colab by Google. So this is a platform provided by Google where you do not have to install any kind of software or IDE on your system, right? So now let me tell you how to use it. So let's cover from hello world, right? So hello world starts with the print statements. So if we want to communicate with the computer, we need to teach it how to speak, right? So now print statement is something that we use to accomplish this. Now this is how we do it, right? So we come to Colab, we use print and say give double quotes, then hello world, right? So now after that, you need to click on connect here. So when you connect, Google Colab allocates a little RAM and runtime for your notebook, right? So it takes a while. So once you do that, you can click on this play button to run the program. So now it is initializing. It got connected. Now let me click to run this. You can see that this is the output. It printed hello world. So this print statement is used to print any kind of statements onto the screen, right? So this is the first part. And now if you look at the next immediate step is to learn about strings. So what is strings? Strings is nothing but a series of letters, numbers, symbols, right? So now strings can be defined in different ways. So the first way is just write print and write the whole statement or paragraph that you want and include it in double quotes, right? So let us try doing that. Say welcome to Pixeltests. So it would run. You can run it, and you can even combine multiple strings using the symbol plus, right? So let's just say print I will, and I'm giving a plus, and say is it Python, right? So when you run it, it will print I will ace at Python, right? So you have printed, you combined or concatenated to the ace at Python the second string with the first string, right? And there are a few common errors what people do while using print statements or strings is mismatched codes. So what happens is you put either let's just say, let's remove this, you mismatch codes. First you start with double quote and maybe end with a single quote. Now if you run that, now what happens is you will get a syntax error, right? And let's just say you do not give any quotes and you just try to print it, so it will still give you error. So these are like a few common errors people do because now the machine does not know what to do next, right? So it gives you a little understanding of what you can do, like print and add your parentheses here, missing parentheses in call to print. Did you mean? So it is helping you, right? Now this is what we learn in strings. It's a very simple concept. Now variables. When we come to variables, what are variables, right? So we need to include a little data that keeps on changing, right? So this data could be the location of a plane, time of the day, or the Netflix show that you're watching, right? So it keeps changing, right? It's not just static. So the only important thing that we need to remember is how do we define it. So let's see that. Now what we do is we define it with the symbol equal to, and before on the left hand side we write the name of the variable. Now here greeting message and says namaste from Pixeltest, right? So now you can next time say hello from Pixeltest. Next time you can say hi from Pixeltest. Now you can change it. Now we are saving it in greeting message, right? It's like the envelope. Now let us do that. So now what I'm trying to do here is, okay, yeah, so let's add a new code, and we're going to use greeting message. So see that you don't have any space after the equal to sign, and let's say hello from Pixeltest. Now if I run it, it will directly save hello from Pixeltest as a string in greeting message variable, right? So now to print it, we are going to say print greeting underscore message, right? Now you can run this. Now see, you have printed hello from Pixeltest, right? So you can state a lot of things, just save a lot of things this way. Now let's just say current underscore lesson equal to 3. Now not instead of string, I'm giving a numeric, and I'm just going to say print current underscore lesson. Let's run this. Now that particular variable got printed. Variables are very useful, right? So now what we do is, like, you can even put up your dates, like, today's date equal to, you can save the date. So let us try to do that. Today's underscore date equal to, let's just say 16. Okay, let's keep it as a string. 16 November 22. Now instead of printing it here, it's today underscore date, right? So now it will print, it will run all these, right? So now that got printed. So now that's about variables. Now if we proceed further, we go to arithmetic. So now the basic form of arithmetic, you can see, is your calculator. So it computes all your symbols, multiplication and addition, and all the other functions also, right? So now the same way we use Python, the way we concatenated two strings, we can add two numbers, we can multiply, we can subtract with the common symbols that we use. We use asterisk to multiply two numbers, right? So if you see them, let's just say the same way, we just go code and say now apples equal to 2 baskets, 3 each, right? So now let's just say print apples I can see the product is 6. So now this is how you can use arithmetic on variables. And if you want to, there's a new operator that Python introduces, which is the modulo operator. Now modulo operator is something that returns the reminder. Like if you want to know what is the reminder when one particular number is divided by 1 or 2 or 3 or any other number, you can just check it, right? So let me just do that. So this helps you in trying to understand if a number is divisible. So now while doing programming, this comes handy. So we are going to show you how it works. So let's just say now we want to know what is the remainder when 151 is divided by 2, right? It is 1. So now the remainder. So what we have done, we have saved this reminder in the variable called reminder. Now let's say print reminder, right? Let's run it. Now you see we have printed 1, right? So now let's just say if you want to divide it by 3 and know what is the remainder, it's still 1, right? So that's how this works, right? So now let's just say 150 divided by 2, remainder would be 0, right? So 2 into 75 is 150 and there's nothing remains. So you can check if numbers are divisible by other numbers, with the modulo operator, right? So the percentage here behaves differently. It is called the modulo operator. Now, if we come back to this, the final concept for this is comments. Now, what happens is Python runs every line that it comes across. But if you want it to not run some part, some statement, that is where we use comments. So the machine does not run this code. It is only used for humans to read. So we want to write code that is understood by somebody else if they reads it, or even if you want to leave notes for yourself in future, right? So you just have to use an asterisk symbol and work it. So let's just say, let's do this. We put up code. Now this is city population is, let's just say 13, right? Now what we want to tell them is what this city pop means. So we just say city population is stored as city underscore pop, right? Or you just say, okay, you can say anything, right? So you can just run it. So this particular line does not run, right? So let me show it to you. Let me write it below. This says city population. And say print city underscore pop, right? Now below that, let me say this prints population. Let's run this. So now if you see, the population was saved and the population was printed, but these lines did not run. So if you want to write something like this without the asterisk, you'll run into an error, right? So this is one common error that people do. People write comment and they do not updating variable numbers, types of divisions, multi-line strings, booleans, and value errors. So yesterday we have covered the first 5 topics. Now let's cover the updating variables, right? So now let's first head to our collab. Now I'm going to create a new collab. So while it is setting up, let's understand why we need to update variables, like as we have discussed variables yesterday. Now let's just say this is an example. Now there is a variable which says fish in pond is 50, and now catching fish has started. Now there are 50, out of 50, number of fish caught is 10. So now the new number is fish in pond minus number of fish caught, right? So this is how the variable that had 50 earlier now is going to hold 40, right? So this is a very frequent arithmetic that we keep doing in Python. So like x equal to x minus y or x plus y. So with the same variable, we are going to subtract or add something to it. So for that reason, Python for this own sake has its own shorthand, which works something like this. Let's just say there is a problem statement which is from January to June, the rainfall has been given to us, right? So we have Jan, Feb, and every month's rainfall in numeric has been given. Now annual rainfall has to be calculated. Now let's just say it's June month, so equal to January to June rainfall. So it is sum of all of this. Now let's just say there's 1 month passed and the July rainfall is 1.05. Now, what is the annual rainfall till that particular month? We have to be checking that, right? So how do we do that? So let's first copy this, come here, and let me parallelly connect. In the meanwhile, I'm going to paste it here, name Python syntax 2, right? So we're here, right? Annual rainfall is all there. Now the new annual rainfall is, one way is whatever earlier annual rainfall was there plus July rainfall, right? To understand what happened, let's try to print it. Print annual rainfall. Yes, now we can see that this is the rainfall till July. But now, if let's just say we have the whole year passed on, right? So there's other way to do it as well, right? So how do we do that? The shorthand that we want to introduce here is, instead of this, let me comment this. We have learned commenting earlier. Just going to do annual rainfall plus equal to July rainfall, which means add July rainfall to annual rainfall, whatever the earlier number was. Now, if I print it, the number is still the same. So this is the shorthand that we are going to use very often. To understand it in a better way, let's see how we can do it further, right? So now August rainfall is so and so. Let's do it here itself. August rainfall is 4.91. Now August rainfall equal to annual rainfall is plus equal to August underscore rainfall. Now we print it, it will add 4.91 to whatever earlier was there, right? So this is how it works. Now for us, the task is to do the same for all the months. So how do we do that? Now let's do annual rainfall plus equal to, we are going to do September underscore rainfall. Okay, let's print it at every step because this is fundamental, so you need to understand how it is working, right? So now the first, this was there, the September rainfall got added. Now we are going to add to annual rainfall plus equal to October rainfall. We are printing it. Now that got added. Now let's not do it for every month. Now let's do it twice. August rainfall plus equal to November rainfall and annual rainfall plus equal to December rainfall, right? So now if we print it now, this would be the actual annual rainfall from Jan till December. So this shorthand we are going to use very often. Now if you see here the same way, we can do minus equal to also, let's say, which means from the whatever variable we have, subtract this particular variable, right? So let's run it. So it's going to subtract the variable, the December rainfall, from what November rainfall was, right? So if you see, right? So this is how we use this shorthand notation. So updating variables, the concept behind it, the shorthand we have understood. Now let's see the types of numbers. This is a fairly simple concept, but a very important fundamental. So in Python, we have different types of data types, right? So first is the integer data type. Now we have this is int. So let's just say int1 equal to 9, right? So now when you save a variable, define a variable, and give it numeric without any decimals and all, it is saved as a integer. Now the other data type is float data type. Here float is something which is 9.1, right? So now this is how this works. Now whenever we have decimals, that particular variable becomes a float. So instead, how we do it in Java and all, first you need to define a variable and all. In Python you do not have to do that. If you give a variable, it is automatically assigning the right kind of data type to that, right? So there are two data types, but what happens when you divide integer with a float, right? So let's just say now we do, so let's come here. If we want to define a float, there's another way, right? How do we do that? Let's just say float is 9.1. Even if you put 9 dot, like the decimal point, that particular variable is defined as a float, right? So towards the end, if you add a dot, that variable is considered as a float. So even this will not throw an error, right? So the variable has been defined as float and it has stored 9.0, right? So let us print that. Print float1. See what is going to print it. 9.0. So we have defined it as a float. So this decimal point also helps, yeah. So now let's try doing a product of an integer with a float. So because this is a simple one, I'm just going to print and just show it to you. So what we have done, there are cucumbers which are 10. This is defined as an integer. Price per cucumber is 3.25. The total cost would be 10 times 3.25. Now when we print it, it is going to print a float number because we have multiplied an integer with a float, and if the output is also going to be a float, right? So this is two important data types in numbers, right? So now the division that I was talking about. Now let's just say if we are trying to divide an integer with an integer, the quotient is also an integer, right? Which makes sense. Now what happens if we divide an integer with an integer and the value of the quotient is still, it's going to be 3. Let us try doing that. Say quotient of this, let's remove the space before, okay, and let's say print right? So now it has automatically converted that into a float, right? But if at all you want to force it to say that you want this output to be a float, right? So in that case, what you can do is you can write it in a different way. You can just say float 7 by 2. Now what you're doing here is you're saying convert this 7 into a float and divide it by 2. So as one of the variable is a float, the product will also be the division will also be a float. So this is another way of doing the same thing, because now Python here by itself is understanding that this is going to be a float, outputted float, The other way is you say that this is going to be a float. Now, this does not come handy when you are using a numeric, right? So let us see an example, so how it works, right? So now let's just say there are 100 cucumbers and there are number of people is 6. Now, if we want the output of this, let's say cucumbers 100, number of people is 6. Let's only try looking at float cucumbers per person. Now here float of numeric does not make sense. Now what you have done, this variable, you have converted this into a float and then try to print it. So then try to define it onto this particular variable. Let's try to print it. Print and let's see. Yeah, so now it is 16.66. The number, it's going to be a float number. Now let's try doing it without this. It's still going to be the same, but you know, if at all, just in case if ever you want to convert it to float, you can just go ahead and do that, right? So this function, this method is something that will come handy at times, right? So we have understood how division of integers work and how division of integer with float works, and how we can force a number to be float by using the float method, right? So now multi-line strings, this is also a very fairly very common and useful concept. Now if you see there's a variable and you want to have a multi-line comment or multi-line string, right? So what do you want to do is, instead of defining a, let's just say multi-line string is multi-line string equal to, now I'm just trying to do double quotes and say plot 10, and I'm just giving a enter and say Hyderabad and say 0 and say India. Okay, so now if you see, I am trying to do it and it's already showing me an error, right? So now how do we write a multi-line string? Now the way to do it is you give three double quotes, right? So when you do that, this works. So now if I am trying to print this multi-line string, I can do that, right? So it got printed, right? So if at all you want to print multi-line strings, this is how you're going to do it, right? Now the other way, if you're not defining it, if you're not defining a variable and still writing something between three quotes, what it's going to do is just going to show you in this particular format, right? So the best way is always to define it and you use the triple quotes to have multi-line strings, right? So these are very simple concepts. And this Booleans, now if you commit Booleans, it is nothing but if you want to save, if it is green light right now, it is true or false. If it is red light right now, it's true or false, right? So you can always you can save in a variable if it is going to be true or false. Let's just say this is small task here. Now we have somebody introducing ourselves, somebody introducing themselves. Let's just say, hi, I am Maria and I live in this particular program and I'm expert Python coder. I am 21-year-old and I plan to program cool stuff forever. Now we have to say, now if there's a question, what is the question? Is age is 12. Is the age 12? What is the name, right? So let me just show that. This is the comment. Now what is the age? Is the age 12? Now we can see that it is not. So either you can say as 0, which means it is false, or you can write false, right? And is the name Maria? Now it is true, that you can write 1, or you can write true, right? So false and true, they, you know, translate to 0 or 1, right? Now, sorry, let's remove this, right? So it saved this, and later if you want to know if the age is 12 or not, you'll know that it's true or not, right? Just yeah, so it's false. Sorry, so that was not all caps. It's camel case. Yeah. So now if you see here, we have this question where somebody is introducing themselves, telling that they are 21-year-old and their name is Maria. Now, if the variable is the age 12, now we know that it's not, it's 21. So you can pass on false as a, you can define it as false, and you can define name is Maria as true, right? Then you can print whatever is needed. So you can use Booleans time to time for a lot of things that we are going to do in the further next sessions. Now the value errors. Now what happens if we want to print along with a numeric and a string? Like, let's just say we see somebody has defined the age as 13, and we have defined age as 13, and now we want to say I am plus age plus years old, right? Now if you see here, there's a type error. So this is what we want to cover here. Now why is this happening? Because this is a string and this is a string, and we are trying to concatenate between that integer. So now it will not be possible directly. So we need to convert this integer to a string. So how do we do that? We use this method called str. So this is going to convert the age into a string. Now it shows I am 13-year-old. So this comes handy. This is how we do. And even if you see string addition, if you put integer, a numeric between double quotes, it becomes a string. So anything that Python comes across between double quotes, it considers as a string. So you can even add to strings that way. So it will not give you the sum, right? So if you go ahead and try this out. Right, so I'm just trying to go to, let us try printing it. String addition. Now, you might expect 100 plus 10, which is 110, but that is not how it works. So it is just going to add both of them, right? So you need to be sure that if you want to be numeric, you have it as without the double quotes. Now this comes as a string addition, right? So now if you can always see that if there is a string now which is holding a numeric, you can always convert it back to float, right? Float or integer by using these methods. If you remember, we have learned about the method. Now let's just try printing this is sir is less string number. See what is going to happen. For now, let's just comment this. Okay. Now, if you see here, the string number, this is a string here because it is between double quotes, and it easily sorry. So it easily got concatenated with another string, right? So now what do we do if you want this to be a number, right? So now we use the float method and convert this variable into a float. Then you can go ahead and print it, right? So this is how this works. Here it's a string and here it's a float, right? So using int on a floating point numeric converts a number to an integer by removing the decimal point and rounding it to the number close towards 0, right? So this is what happens if you try to do a 7.5 and convert it into an integer, is going to be just 7, right? So the challenge here we faced is now int cannot convert a string, right? So let's just say if this was a float underscore number, and let's say we are going to convert this to float underscore num and try running it. So it got converted and you lost the decimal, right? So you can convert it from float to integer as well, right? So, if you look at a task, if you multiply a float with a float, you'll get the product as a float. And if you want to print it as a string, you need to use the method str, right? In today's session, we are going to continue learning fundamentals. And in that, we are going to cover strings. So we'll learn how to access characters of a string by index and a few methods of strings and how to format strings. So let's understand what is index, right? If you break down a string, the characters of the string are numbered, and these numbers are called index. Each number is called the index. Now, if you see in this Python, the first character P is indexed as 0, and subsequently 1, 2, 3. That is how it goes in an increment of 1. Now, if at all you want to know what is the fifth letter of this particular string, you would need to access the character which is at the index 4. Now let's just say try to do this with an example. Now my collab is ready. Let's just say there's a variable that we have defined which is called the first letter, and then there is string. So now how do we access a particular character in the string is with the index. Now we open a square bracket and we give the index number. Now if I give 0, it will pick up the first character, which is C, and save it in the variable first letter. Let's try to print first letter, right? So now the output will be C. So let's look at the assignment. We have to define a variable which should save the fifth letter of this string called Monty. Now, if the string is Monty, double brackets, now we need the fifth letter. Now, fifth letter means the fourth index because it's starting from 0. Now, if you give it 4 and we try to print the fifth letter, it is going to give us by. Now, let's move on to the next thing, which is a few methods of the strings, right? Now, these are very straightforward. Let's directly get on to the assignment. Let's go into the code. Now, the first two methods that we are going to see is length and string, len and str. Now, they have already given us a variable which is word. It has the string exhibition into it. Now, if at all we want to know the length of this particular variable, we will just pass in the variable and then print the variable which is length. Now, when you print it, it will give the number of characters that this particular string has, right? Now, even if you look at trying to use the second method, which is str, let me show. We have already seen a little about it. Now we have defined a variable which is pi and given it a numeric, a float 3.14. Now if I am trying to print this, it will give me an error because this is a string and we are trying to concatenate it with a float, right? So now how do you convert this into a string, right? So now you use the method str and let's try rerunning it. The value of pi is around 3.14, right? So now we have successfully converted it into string and then we got concatenated with the string given. Correct. So now let's move on. Now, if you see, the next methods are also fairly simple. Let's come here and let's see what we want to call lower and upper methods using the dot notation. So let me tell you what is the dot notation. Now, this word variable has the string exhibition, and if you want to have the whole of the exhibition in lowercase, now you can see that E is capital right now. If I'm going to do word dot lower method, if I'm calling this method this and I'm trying to print it, this is going to give me this word in lowercase. Now if you see, this method is called using the dot notation. This is called the dot notation, and the dot notation is used for strings. Why we have not used length and string like that? Because it can also work with other data types, but lower and upper work with strings alone. So that is why we are using this dot notation. And if I'm going to print it, it's going to give me in all small case. Now if I'm going to use the same with the upper method, it's going to give me the all caps. Let's move on. Now in strings, if we see how to format strings, we have seen earlier how we have concatenated a variable with a string by converting it into a string, but there is a better way, right? So we use this percentage operator here, and do it. So let me show it to you. Now there are two strings. The first string is red light and second string is green light. Now we want to print a statement which says go when it is green light and stop when it is red light, right? So how do we do that without trying to concatenate in a complex way, right? So this is how we do. Now we have this whole string stop when it is a, now this is the placeholder. Here we are going to use this %s and replace it with red light, and then go when it is a %s and replace it with green light. Now how do we do that? So we write print statement, then write our string and put the placeholder %s wherever we want the variable, and just after the string we put the operator % again, and in brackets comma separated we are going to write these names of these variables, write these variables. Now how this will work is print stop when it is and it will start looking for the variable here after the % operator and replace it here, and then go when it is then again it will look for the second variable in this particular brackets and replace it. So let's try doing it. So this is how it will work. So stop when it is a red light and go when it is a green, right? So this is how, let us try to do a little assignment. Now we have been given three variables, which is name, quest, and color. The name is Pixeltests, the quest is teaching Python, and the color is green, right? So now we have to print. So your name is, here there is a blank. We need to bring what is that we need to be adding here is %s. Your quest is the second variable %s, and your favorite color is %s, right? So now let's put the brackets here, and then here there is another blank. Here we are going to put another %, and name, quest, and color will be replaced. The %s will be replaced with name, quest, and color variables, whatever string is there in that particular variable, right? So it will not give us an error. So this is how we format our strings. In this session, we are going to learn fundamentals, and in that we are going to cover date, time, and operators. How do we get information? How do we extract information about date and time, and a few operators that we will be using in our conditionals, which will be the next module, right? So let's get started with the date and time. How do we get the current date and time? Now if you look at this particular statement, we use this function called datetime.now, right? And here we use this line from datetime import datetime. So what this line does is it imports the datetime library. So in those libraries, these functions are all already written. Let's go ahead and test it. So I have my collab ready, and we would say print now. So what we have done, we have imported the datetime library and assigned the current date time information to a variable called now and printing the now. You can see that we have the date and time, and this time is very detailed. Now if I rerun it, it will get updated by a few more seconds, right? So now earlier it was 21, now it is 26, right? So this is how we have got the time. Let us move forward and see what all things we can do, right? But this is not the date and time information that we want every time, right? We would want just to print it in a different format. So let's see how we can try extracting specific information for our need. Let's save the date and current date and time in the variable now. And we have created 3 new variables, current, year, month, and day. And we have used now.year to save the current year in this particular variable. Similarly, for now.month and now.day. Now these variables are holding the current year, month, and day. And now we are going to print these variables. What we can do is directly print current year, current month, and current day. Now you can see the year, the month, and the day have been extracted. But how do we put it in a better string format, right? So now you know how to concatenate by using print statements plus str functions, methods, string methods, but there are better ways to do that. Let's go ahead and try them. So how do we do that? Yeah, so we do it with using this formatting methods. Like this is, we are going to format the string this way. Now what this particular statement does, let's try to understand. Now d is the integer. Now after the percentage operator, whatever variable is there, the first variable gets replaced here, the second replaced here, and third here. So now what this 0 to d means is the integer, whatever we are going to pick up, will be of 2 characters, and we'll be adding a padding 0 if there is no character. For example, it could be 11, 31, or any number like that. It will be a 2-digit integer, and 0 means if, for example, if it's single digit, let's just say 6 or 9, it is going to add a 0 in front of it. So if the date would be 6th November, it will become 06-11. So that's how it will be, right? So let us try to run this. Now you can see that we have month, day, and year format here, right? Similarly, we can do this for time. After understanding this, it becomes very easy. Now what we do is we use the same function datetime.now, but we are going to use the variable .hour.minute.second to extract only hour, minute, or second information, right? So let's try doing that. And let me comment this particular line current for now, right? So it is 19th hour, 55th minute, and 8 seconds. Now if I rerun it, it is 21 seconds, right? So that's how we have also extracted the time information. And to format the time also, we use the same notation and use it this way, right? Just the variables change, nothing else changes, right? So let's add the braces. We have a better understanding of it. Now here the percentage 04d meant the integer that we will be picking up from here will be of 4 characters, and if it is less than 4 characters, pad it with 0. Let's try running it again. You can see this is how this keeps on adding the padding of 0, right? If you want to run a little complex formatting of date and time, you could do something like this, and each percentage d will pick up the corresponding variable and take it to the number of decimal points mentioned and pads it with 0 if it is lesser than the said number of digits. Now let us try to understand operators. We'll come across a lot of operators going forward, but these are the important things to know before we proceed on to our next modules. Now you see, these are in mathematics, we use them very often: equal to, not equal to, less than or equal to, greater than or equal to. So now how the notation is, now because we use equal to in general for defining a variable, we use double equals to say the left hand side equals the right hand side, right? So, and an exclamation equal to tells that this is not equal to, right? So we'll see the examples. Less than is simple, less than equal to is simple, greater than is understandable. We use the symbols. Greater than equal to is also understandable. The thing that you need to note is double equal to compares when two things are equal, whether if the two things are equal or not, and equal to assigns the value to the variable, right? So this is an example. Now Boolean operators are also simple. Now let's see how these operators work: and, or not. Let's go to our Colab and say bool underscore 1 equals. Now what happens is the output of Boolean operators is going to be Boolean, which is 0 or 1. Now what we are trying to do is see if this is true or false. If 1 is 1 less than 2, yes, that is true. Is 2 less than 3, and that is true. So when we have both true statements, the output would also be true. So let's try to print bool underscore 1. Let's see if the output is true or 1, right? It's true, right? And let's just say if it was 1 is false and other is true, it is going to be a false, right? When this is how the and operator and Boolean operator works, right? So now let's check how the or operator works. Is the same thing, but say bool underscore 2 equals the same operator. Now what we are going to do is print bool underscore 2. Now 1 less than 2, that's true, and 2 greater than 3 is false. Now we are asking true or false. So when it is an or operator, if one of them is true, the output is going to be true, right? It's only false when both of them are false, right? So let's just say 1 is greater than 3 or 2 is greater than 3. So now what this does is it will check if 2 is greater than 3, and it returns false, and it checks 1 greater than 2 and returns false, and false or false becomes false, right? So this is how the or operator also is used. Now let's see how not operator works. This is very simple. If it's not true, means it's false. If it's not false, it is going to be still false. Not false is true and not true is false. Right? How is it going to work? Not true is false, and not false is true, and not true is false. So this is how the not operator works. It just reverses the Boolean, whatever is there, right? A few notes: if you are trying to use not and or in a same statement, not is evaluated first, right? So for example, true or not false and false. So here it will evaluate not false first, and this statement will become true, and then and is evaluated, true and false becomes false, and true or false becomes true, right? So this will be the output. So the best way to evaluate in such cases is use parentheses. Now, whenever you use parentheses, the the brackets, it ensures that that particular unit is evaluated on its own, and then the operator works as usual, right? So let's do this final check. True or not false, as we thought is true or false. So that becomes true. So in this session, we are going to continue learning fundamentals. We'll see conditionals, if, else, and else if statements, a few methods, and an exercise to follow. So let's dive in. So what are conditionals and control flow? We want many times our code to make decisions. Conditionals and control flow give us the ability to choose among the outcomes based upon what is happening in the program. So we'll see this through an exercise. Let's see how the syntax of this all goes. In our previous sessions, we have seen equal to and double equal to difference. Now, if you see animal equal to tiger, here we have saved the value tiger into animal, the string. Now, if animal double equals means if animal is tiger, then print, there's a statement which says the animal is tiger. So now this if statement will only execute the print, whatever statement is there below the if statement will only execute when animal has the value of tiger in it. So we have given this code ability to execute a line only when the condition is true, right? So now a few things to note is the indentation. When you move a particular statement by using a space or a tab, this is called indentation, and this is very crucial in Python. Whenever you indent one particular statement below other, the indented statement, the statement that is inside, is considered as a block which is part of the above statement, right? So we'll see a little about a little of function. Now if you see DEF, which means definition, so we are defining a function which is called greater than, less than, or equal to 5. So now we have created a function greater than, less, equal 5. Now answer is going to be a variable. So let's go and execute this here. We have our collab ready. Okay, now let's check how this is going to work. So what this does is this defines a function greater than, less, equal, and a variable is being passed, which is answer, right? So here what we would do is, like, for example, somebody is calling this function and passing a number which is like, let's example 4. So what do we want here is, if answer, whatever is being passed here, is less than 5, return 1. Else if means if it is not 5, if that statement is not true, run this function. Answer is greater than 5, return -1. Else, which is the equal case, and then return 0. Okay, so let us see how this runs. I'm going to print these 3 statements. Let's see what would happen with 5. Now this function greater than, less, equal 5 is being passed as answer, and if is 5 less than 5, no, so it will not return 1. Else if it will check, is it greater than 5? No, it is not, it is equal, so it is going to return 0. So similarly 4 and 6 also will return something. Let us try running this. Now you can see that this is how the program chose based upon whatever variable, whatever we wanted to test, right? So this is how this is a small definition of a function, but you can see the power of this particular statement. You can always use such functions and keep checking based upon. You can always use such functions to test. See, now what happens? I'm going to print whatever is being returned by this function, and this function we are passing the value 9, and the function is going to return something. Now it has returned -1, which means that it is greater than 5, right? So based upon what is returned, we can do a lot of other things to follow. We'll see this in detailed in our next exercises. So the best way to learn always is through trying this. So if, else, and else if is all covered in this particular code assignment. Now we have a grade calculator. If at all the score by a student is 90 or higher, then we should grade him as A. If it is between 80, 89, B, 70, 79, C, 65, 69, D, else it is an F grade, right? So similarly, like above, there is a definition. The function is grade calculator, and whatever value we'll be passing will be the saved into grade, and here we should write our conditional. Now if grade, the first statement is 90 or higher, means it could also be equal to. Okay, so if it is greater than or equal to 90, then return A. Else if from 80 to 89, similarly here, if it is greater than equal to 80 and less than 89, when both of these are true, grade B has to be assigned. And similarly, we are going to, else if means if not that, then test this conditional 70 to 79, return C. Else if check 65, grade is, if the grade is greater than or equal to 65 or less than 69, less than, it could be less than or equal to, because even it could be 89, 79 or 69, then return D. If none of these, then return F, right? So let's test this. Okay, so just parentheses, adding the parentheses of brackets here. Right, so let's run this. Okay, somebody who's got 61 got a F grade, somebody who's got 70 got a C, and somebody's got 92 got an A. So we were able to define a small function and also used conditionals to let the program return based upon if it is true or false, right? So this is how we use if, else, or else if. In this session, we are going to learn about functions, what are functions, parameters and arguments, call and responses, functions calling functions, and a little practice, right?
So let us start with what are functions. And in Python coding and Python programming, you would want to use a piece of code, a block of code, again and again. Like for example, if there is a date function, it remains the same everywhere, and you'd want to reuse it. So that is to make the code cleaner, we write these functions. Instead of writing the whole code everywhere, we just call the function alone, and from there we can use it repeatedly. So let us look at this quick uh, definition of a function. Is very preliminary. Now let's go ahead and learn a little more. Okay, so in this function, if you see, this def is the definition. Here the definition of the function is going to happen, and if you see, this is the name of the function, tax, and bill, this is the parameter. Now in parentheses is the parameter. Now parameter means this is a variable that will hold whatever is passed. For example, here if you are passing meal cost, now meal cost will become, no, it will, the bill will be whatever is there in meal cost, and in the end there is something called response, and that function has to return something. Whenever there's a function, the function returns something to something that is called. Like for example, meal with tax is a variable, and we are calling a function tax here, and the variable is meal cost that is being passed as into the parameter. So when we are passing here, this is called the argument. We'll look at it at a later point. Now let's see what is the definition. So now definition, name of the function, and the parameter, then you have to have this colon, and then after that there's a comment here which says this function adds 8% tax to the restaurant bill. Now the whatever parameter we had, bill, it is going to multiply itself by 1.08, which will add the 8% to that particular value. Now we are going to print this, and this is going to return bill. Okay, let's, without calling, let's just see if there's an error in this. Okay, there's no error in here. Okay, so because here we have not called the function, we have just defined it. Now we have defined another function also, which is definition tip, and same the variable parameter is bill here. This is going to add 15% to the tip, to the restaurant bill. Right, now bill, this variable is going to multiply itself by 1.15, which adds the 15%. Now this is going to print with tip. Percentage f here is the float number. Now percentage s is for strings, d is for integers, percentage f is for float. Now what it is going to do is it will take uh, the variable bill and replace it wherever the percentage f is there. Now this printing will be done in the function, and then whoever is calling, wherever it is getting called, there this bill, the updated bill value is returned. Right, so let's try and run, see if there's any error in the whole, both of the definitions. Okay, so there's no error here, and you have to note that there is the indentation in the function, wherever, whenever, if you can see here, there are two spaces which is indenting the body, the block of the code towards the right, telling that all of these lines come in this particular function. So this is the header, and this is the body wherever the function is written, and at the return statement is the response. Now let us go ahead, and there is a variable definition meal cost, which is 100. Right, now meal with tax, let's first try to print that. Right, I'm going to comment the last line. Now you can see with the tax it is 108, which is a float number. Now let's see what happened. Now this tax function was called, and what was passed? 100 was passed into it, which was the meal cost. Now it went, 100 went into the bill. Now bill equal to 100 into 1.08, which is 108. Then print statement with tax percentage f bill, and whatever was there in bill, this came here with tax 108.00. So that is the float. Now return bill. Okay, now this bill was returned to meal with tax. So now meal with tax is going to have 108.00, and and the statement, the print statement printed, also printed what is the updated bill with tax, right? So similarly, let us go ahead and run the next statement also with tip. What it is going to do now, the number is going to be passed to 108, is going to pass to. Now what happened here is the 108 as bill was passed on to the second function, and it was multiplied by 1.15, and that was printed in the statement as above. And then this also was returned, the new updated restaurant bill was returned, and it was saved in meal with tip variable, right? So let us even try to print the variable meal underscore with tax, just to understand it got saved in there, right? So it got saved in there, and that is why it is printing, right? So now if you see, you don't have to actually, if at all you are building an application for this restaurant, you don't have to every time write this function for new values. You just have to write it once, and maybe now if the meal cost becomes 200, the functions are called and the updated numbers flow and are ready for you to use. So this is how this becomes very useful, and we'll see going forward how resourceful this is. Now in call and response, it is very much simple. Now let us go ahead and see this. Now there is a definition of a function which is going to square the number that is passed. Here the parameter is n, and there is a comment. If you remember the multi-line strings, you can use for commenting. And now what is happening is there's a new variable which is called squared, which is equal to n star asterisk and asterisk 2, which is read in programming as n power 2, right? So which is going to just multiply n into n. Now if I'm going to write n power 3, it is going to actually n into n, right? So that's how it works. Now let's fix the print statement, right? What is going to happen here? Percentage d, which is the integer, squared is percentage d again. So now n is being passed here, it will come here n squared. Like for example, here we are passing 10. 10 squared is now whatever squared variable is holding, which is 100. Now return squared, the new variable, that the updated variable is passed, is returned as a response. Now what is the exercise here? We are going to call square of 10. This is called the function call, and when you have passed this number 10, because this is the value, this is called argument, right? Now n is the parameter, the variable title, the name is called parameter, and the value that is passed is called argument. Now the square function is given the argument 10. Now let us run it. You can see this function has now printed 10 squared is 100, right? So this is how you can use this function. Let's say if I want to square 5, I don't have to make much changes inside. Now 5 squared is 25. So this becomes very easy, right? I think you are getting the value of the functions. Now parameters and arguments are also already made understood, but this is quick exercise. Now let us look at, now what we are trying to do is we are trying to define a function which is power, which will take two variables, base and exponent. So how are we going to write it here? Let's just say we are going to pass two parameters, which is base and exponent, right? So and then we have the colon here. What is going to happen? Result is a variable that is defined and it is going to base to the power of exponent. For example, I'm passing 2 and exponent 3, 2 to the power of 3, that result will be 2 into 2 into 2, which is 8, and print percentage d, the integer. Here there'll be a, this is a placeholder for an integer, to the power of another integer. So 2 to the power of 3 is percentage d, which is also another integer. That is going to be the result variable. Now let us give our arguments here, 2 and 3, right? So let us run it. 2 to the power of 3 is 8. Now without making much changes, I'm going to say 3 to the power of 3 is 27. So now we are starting to build. Now if you move forward, you can see that it is also very useful when functions call functions. Even you sometimes have to not just call the function in a body, but call a function in another function. Okay, so that's it. Now let's try to run it. Okay, so we're not printing anywhere right now. So both have got defined just. Now let us try to pass on a function of function underscore 2. Let us pass, for simple calculation, let's pass 2. Now the argument is 2, the function is being called is the second function. I'm going to run it. Now what happened here is, first 2 was passed in here, so it went next line, return function 1 of 2. Now here first this will execute. Now it will go here and it will 2 into 5. It will do 2 into 5 first, 2 into 5, which is 10, then plus 7, and return that to this particular function, like return to the console. Now that is why this 17 got printed here, returned here. Okay, so now that is functions calling functions. We'll see more of that later. Now if you see, we are trying to, let us try writing the statements here in maybe multi-line comments. Okay, now what is being asked here is, define a function called cube. We have started the definition, takes an argument called number. Okay, number, don't forget the parenthesis and colon. Yes, we have not forgotten. Make the function return cube of that number. Okay, so number multiplied by 3, say number to the power of 3 you can do, or let's just simplify and do it now, n into n. Define a second function called, okay, sorry, define a second function called by 3, and this should call cube to the function. So let's just say it's a return cube to the power of number, then which means the parameter is going to be number, and return its result. Okay, and return its result. Okay, so if the number is divisible by 3, then we have to return this. If only it is so it's always good you have to read it first. Let's write a statement. What they are asking is, if whatever number that is coming in, number is number modulo 3. If you remember, this tells us, gives us a reminder, if this is equal to 0, then we'll have a colon again, then you have to indent it a little, then a return cube of number. Otherwise, which is nothing but else, by 3 should return false. Now let us say we also have colon, set semicolon, return false. Okay, so now we have the function here. N is not defined, sorry. Let's, because it's number, let's write it number into number into number, right? Now let's okay, there's no function call. Let's call the function by 3. Let's give a number that is divisible by 3, 9. Okay, first. Okay, so now what happened? It is divisible by 3, perfectly divisible by 3, because 9 by 3 is going to be 0. And then our if statement said, because it is divisible by 3, now cube 9. Right, now the function went here, return 9 into 9 into 9. So let's see what is 9 into 9 into 9. 9 into 9 into 9. 729. So we are perfectly there. Now let's pass something that is not divisible by 3. Let's pass 10, right? Okay. I'm just going to run it. Now you can see that we've used conditionals in function with this exercise, right? So this brings us to the end of this particular session. In today's session, we have progressed. In today's session, we have progressed a little more in our Python learning journey. In our next session, we will see the rest of the functions and how to work with them. Link to the free Python email course, the code snippets and notes for today's session are in the description. So if you like the video, please drop the top 3 learnings in the comment section and do subscribe to the channel. In this session, we are going to continue learning our Python fundamentals, covering the second part of functions. Now, in the previous session, we have seen a little about functions, and here we are going to cover what are imports, generic function imports, universal imports, and a few inbuilt functions that Python already has, right? So let's start with generic imports. Now, what happens is, let's first try asking Python this one particular statement. Let's just say we are going to say print square root of 25. Now it has given us a invalid syntax error, and you might say, Sachi, we have not defined the square root function. That is right, but Python has many modules that work as a library of functions. Now what these which are commonly now you might say, Sachi, that is right, the syntax error is correct because you have not defined the square root function, which is also true. But we don't actually have to define square root function because Python already has a module which works as a library, and the definition of square root is already within that. So what we do is we import this module, and this function starts running. You don't have to write the definitions. There are many such functions that are already defined, and there are many modules which act as libraries. So let us look at a few of them. Now what we are going to do is we are going to say import math, say import math. Now this also will will not immediately run, because it's not just import that we do. And then we say the module name math dot square root. Now what we are telling Python in this statement is go ahead and call the square root function. There are multiple functions in math, but call square root function math dot square root. Now if you see how we call string dot a function module, this is how we are calling a function within this particular module. Now you see the square root of 25 is 5, and we did not have to define the function because it was already done, right? So there are two sides to it. One is there are a lot of importable functions and modules that you have where you get the variables and everything from directly the definition within that particular library or module. And you can also create your own modules and libraries and keep all your definitions in that, so that you just have to import that particular module in single line and start using your functions without cluttering your code, right? So let us see a few practices. So these are called generic imports because this is the simplest way of importing. But there are other imports also which are like function imports. What you do is now if at all you do not want to write this math dot square root every time, so what you can do is there's another way. You say from math import just the square root function. Now you're telling Python that this is the only function that I need, and I don't need any other function that is there in math. So there's no confusion. You don't have to say math dot square root. Now you, even if you give square root, that also is fine because that is the only function that exists. So we have imported a function of the module. Now let us try giving another number and see it worked, right? Now this is function import. The generic import imports everything, and then you have to specify module name dot the function that you want to call, and the prerequisite is you should know what is the name of the function so that you can call it properly, right? So now let us try to understand the other way of import, which is universal imports, right? So now what we tell in this particular type of imports is I say instead of importing square root, I say import everything by giving a symbol called a symbol asterisk. Now what this does is from math import every function, so that you don't actually have to write math dot each function name. They're good and bad sides of this, pros and cons. So now though you are able to use the directly function name instead of writing math dot square root because every function got imported, the challenge is if you have multiple imports. Let's just say you have another function, just say I'm just hypothetical, there is a module that you're calling and you're importing everything from there, and there could be a few variables and few function names that could be common in these, and then Python would not know what you have called, and it is very tough to identify what variable is of what function, and it will all become a little cluttered. So though universal imports provide you a little comfort, but this is not a healthy practice to do imports, right? These are universal imports. And now let us look at a few inbuilt functions. Like these are a few skill sets that the makers of Python have already given to the Python. You don't have to import anything specifically, right? So let's see all of them together. Now what we have not imported anything, but there is a function called max, and this has multiple arguments. Now till now we have seen single arguments where only 9 was passed, 29, 25 such numbers were passed as arguments. Now here this is multiple arguments. We have passed 4, and this function takes multiple arguments, and the response is stored in the variable maximum, right? So let me just take it out from here and see what's happening here. See, you have got the maximum out of these numbers. Similarly, you can do min, and yeah, so it works because the name is still says maximum, but it has minimum saved in it, which is the same. Let's say number, call it number, becomes easier, right? And we've got it. Now there's another function which is called the absolute. Now how absolute works is, you can see a absolute gives the distance of a variable from 0. So it does not return negative. Now 10.5 from 0 is 10.5 units away, and plus 10.5 is also 10 same 10.5 units away. So now what is going to happen here is, it is just going to return 10.5 alone, right? So in a way it removes the minus symbol, but that is not the actual use of absolute. It gives you the distance from 0, right? Now if I'm going to print this, it'll give you 10.5. Even 10.5 will also give 10.5. So this is actually useful when you're doing mathematical calculations and all, right? So still it's good to know that this is also an inbuilt function, right? So now what we do here is the type function. What this type function does is, it returns a data type of your variable or value, right? So now let's see, we are trying to, this is also an inbuilt function, type of 42. Now 42 seems like an integer, so it will return int, and 4.2 is a float, and eggs is a string. So if I'm going to print, it will tell me like what is the type of that particular variable. So this is also an inbuilt function. So it's always good to know there are such inbuilt functions. Now this is the same the function we have already covered. This biggest number is going to use max, and it is going to return max, and smallest is going to do the same. Distance is absolute, biggest, and you can do multiple functions. So what we can do is we can try running this. The biggest number will be 10 here, the smallest will be minus 10 here, distance from 0 will be just 10, right? So this is how we have come to know about a few inbuilt functions, and let us see what is there in practice for us. Okay, we are going to new code because we don't want to run into errors. We are going to multi line comment it by giving triple quotes. What we are being asked is, first define a function. Let's call it shutdown. Okay, then we've given the colon. Don't forget the parenthesis or the colon. Then if the shutdown function receives an s, which means s is the parameter, and if shutdown the call receives yes as an argument, it should return shutting down. Okay, I'm going to give 2 spaces and say return double quotes shutting down. Okay, and alternatively, which is else if s is equal to no, then function should return shutdown aborted. If shutdown gets any other input, then it should return sorry, right? So what we are going to do is we say if s equal to yes colon return shutting down. Okay, and if you can see I have to indent it or else it will not be taken as the block of if. Then else if s double equal to no, then return shut down aborted. And oh sorry, this is not the right way, it is elif, right? Then we have else whatever comes, just return sorry. Okay, so we've done what is asked of. I think here also we do not require the parentheses. Let's try to run it. Somebody has to call it also. Let's say shut down. First let us do the else statement. Say do it. Okay, now what's happening? It said sorry. Okay, so that's not how it works. It said I didn't get that, right? Now I'm just going to say no. And it says shutdown aborted. Okay, now I say yes. Now it says it's shutting down, right? So we have used a little of whatever we have learned here. In this session we are going to cover lists and dictionaries, and we are going to see how to access by index, how to update values, length, slicing, and maintaining order, right? So now if you look at lists and dictionaries, so what are lists? Lists are very much like strings only. Here you can have multiple elements which could be of different data types. So let us look at this with an example. Now in this list I'm going to first define a variable zoo animals, and I am going to use square brackets here, and I'm giving strings, 4 strings here, right? Now if you look at the statement here, we have a print statement. Okay, so let me first run these 2 statements and see. So what is happening here is we have defined a list and given it in that list we have given 4 items, and out of those 4 items we have printed the first 2 items. Then how did we print it? With the print function, print statement. The first animal at the zoo is plus zoo animals of 0. Now this is accessing by index. Now if you can see, we have accessed the first element, which is pangolin, out of this zoo animals list. Now 1 is the second animal. Now 3 would be sloth, 4 would be peacock, like 0, 1, 2, 3. 2 would be sloth and 3 would be peacock. So you have to remember that it starts from 0 like strings, right? So now if you look at a little more examples, let us check the same here. Now we have another list which has now a data type of integers 5, 6, 7, 8. Now the list is created. Now what are we trying to do here is we are going to print adding the numbers at indices 0 and 2, right? Which means we are trying to
add numbers, the name of the list and the index 0 plus numbers to which is the index for the second. So now 0 would be 5, and the value at index 2 is 7. So if we try to print it here, let's check. It's going to print 5 plus 7, which is 12, right? So pretty much very much like strings. Now how do we update values? We just go ahead and reassign another value. Let's just say here, let's do the same thing. Changes. Okay, now at zoo animals 2, what do we have? 0 1 2, we have sloth, and right now here we are trying to equate and reassign it with hyena, right? So let's see if there's an exception here. Let's try to run it. Okay, I've just removed the space. Okay, now let us try printing the animal at the index 2. Yeah, the animal is sloth, right? Okay, let's just say 0 1 2. Did we? Oh, okay, so this is before. Okay, so we have done a mistake here. We are giving the print statement here. Now you can see after the reassigning, now it is going to print the new statement. Now we can see expected and indent. Okay, let's take it inside and then print it. The second animal at the zoo is hyena. Now you can see that we have changed and updated the value of that particular list, right? And now moving forward, the length of list is also pretty much simple. Now what do you write is len, len of the name of that particular list, right? So I'm just going to say length of zoo, say zoo underscore animals, and I'm just going to write print of this, right? Let's try to run it. Now the length is 4. So that is also pretty much straightforward. And now the lists, the lists are always very much editable. Now if you see, there is a list which is a suitcase. Now this is an empty list we have given, just to square brackets, it's an empty list. Now when we use this list function, dot append, and in that particular parentheses we give that string or integer, this gets added here, right? So let's just try to print suitcase first. What is coming in here? You can see that there's only sunglasses, right? So now we have appended dot append. Append is nothing but add to end, right? So it will get added towards the end. Now we are adding 3 new strings. So that first let us see what is the suitcase printing now. The suitcase has 4 items, right? Okay, now list length is length of suitcase, because we have seen the same length of parenthesis suitcase. Now there are percentage d items. Now here the integer placeholder is there. Here list length will come, which is 4 items. There are 4 items in the suitcase, and those items are the ones below, right? So this is how you
append and know the length of a particular list. Now slicing is also easy. Now basically what happens is we do not want every time whole of the list, right? Maybe we just want the second and third item, like maybe we want students only in the second bench, not the whole row. Now that for that reason we use slicing. Now how slicing works is, let's go ahead and try to add a new code piece. Now we have suitcase, the list, and you see the first index is from where to start. Now 0 is sunglasses, 1 and 2 is passport. So the 2 is excluded. You will not have, when we write 0 to 2, which means just give 0 and 1. So it will print the last whatever digit is there minus 1. So when, like for example, let's try to print first. Okay, I'm going to remove this. Now you can see that we only have sunglasses and hat. So it is not 0, 1 and 2, it is only 0, 1. So if I have to print the passport also, then I should say 0 to 3. Now what is going to do is, it is going to take the first 3 items here, right? So the last index does not take that particular item. Now for example, if we just want from 1 to 3, which is hat and passport, you can just give slice the list using this way. Like now the first the variable first is a slice of the actual suitcase list, and it only has 2 items in it which are actually in the suitcase, Now when we create a slice, this does not edit the main items in the suitcase, right? So if I try to print what is there in the suitcase, you will still see all of the items still there. So you're not deleting anything, you're just slicing and putting it in another variable, which is also a list, right? So this slicing is also easy. Now if you want to slice something inclusive, like just to add on, we have another list. Now animals, we have, this is a string, just say cat, dog, frog, without any spaces, we have the string. Now you can see the first 3 characters of animal. If you just want the first 3 characters, you need not mention if you are from 0, you can always leave it as empty and say colon and till where you want. Now so the cat in this variable, it will have an cat, because 0, 1, 2. So all these things will come here. And if you want towards the end, if you do not want, you do not know, like you want to say from second bench everyone get up, right? You don't want to say from second bench get up till the 10th bench. You want to say, then you say from 6 colon and leave the last one here, right? So now I'm just going to print cat and remove this for now. Now you will see that there is cat. I'm just going to say I'm just going to make it 0 to 6, right? So it will, the cat will have no cat dog, right? So that is how this works. But if I say I want from 4 to 6, it will just have OG, right? So if I want from 7 till the end, right, it is going to give me FROG, like ROG, right? So I just say 6. So it will take from the 6th index, 0, 1, 2, 3, 4, 5, 6. 6 is F, from F till the end, right?
So this way you can have the first three characters without having the first mentioning the first zero, and towards the end also you can leave that particular number, right? Now maintaining order is nothing but sorting any particular list. Now if you look at this particular statement, let us try to run this. Now we have animals, and the list has 6 strings, right? Now animal dot index duck, which means return whatever index wherever duck is there. Now it will return 0, 1, 2. Now 2 will be saved in duck index. Now if I want to insert something else instead of duck in that particular list, you can use the insert function, which says animals.insert duck index, which is 2 comma cobra, right? So first let us try to print it 2 places. Now first I'm going to print it before the insert statement. Let's print animals. Now we have all the 6 animals. Now we are going to print what is there in the duck index, right, which will be 2, and then we are going to run this insert function 2 comma cobra, right? So now let us run after this. Now you can see the duck index had 2. At index 2 we used dot insert to insert at the index 2 cobra, right? So you can see that instead of replacing, we have just inserted a new animal at one particular index, right? So this is how you have used dot insert, and you have used dot index, and you have also used dot append to better organize your lists, right? So in this session we are going to learn a little more about dictionaries. Now in dictionaries we'll see how to expand from lists, do more with for loops, updating values in dictionaries, what are keys, new entries in dictionaries, deleting from dictionary, and how to remove a few things alone, and mixed dictionaries also, right? So let us start with what all things we can do with lists and for loops, right? So let us directly get into the for loop here. Now here we have created a list which is start underscore list, and it's a list of integers. It has 5 integers. Now we have defined an empty list with the square braces, the parentheses, square parentheses. Now what we are right now trying to do is we are using something called a for loop, which we'll learn more going forward. Now here for number is nothing but a variable that keeps on updating, right? For example, now let me also print what is number, so it will become easier. For number in start list, which means there are 1, 2, 3, 4, 5. So there are 5 items in the list. So for 5, right, now the numbers would be 5, and it will start from 1, 2, 3, 4, 5. Like it will be like that, right? Now square underscore list dot append number to the power of 2, because we are trying to do a square of every number. Now what we are trying to do is for every time we run this loop, we are going to add the square of the number. Now what is the number? This number is the element taken from that particular string. Like for example, if the first iteration, if it is running, the number would be 5. The second iteration, it would be 3. So which means for the first iteration it will be 5 to the power of 2, second time it will be 3 to the power of 2. Then after running this, there is another function that we are trying to use, which is dot sort, right? So we have seen dot index, dot append. Similarly, we are also trying to see dot sort here, and then we are going to print the square of square underscore list, right? So just to help you with what is number holding right now, I'm just going to write print number. Let's say current number is, give space, say plus. We are trying to convert this from number to string, right? Because print cannot print the concatenate a string with a integer, right? So let us try to run it. Now current number is 5. When the number was 5, it came here. It first did number to the power of 2, and which means 25, and that 25 was appended to this particular list. So now the list would have 25, 9, 1, 4, and 16, right? 4 4s are 16. Now then the function dot sort ran and sorted it in order 1, 4, 9, 16, 25. Now we have printed it again. So now you can see that with the help of for loop, we were able to operate on each of the single number of that particular list. And with the help of dot sort, we were able to sort the list and print it, right? So that's about for. And now if you look at what all things we can do more, it is something similar. We've already covered the sort function. So here what is going to happen? Animals, there are 3 animals in the list string. Now if we sort it, it will be in the alphabetical order. Now cat and bat will become and bat and cat, ABC, right? So that's the sort function which we have covered. Now coming to dictionaries. Now what happens in dictionaries is it is very much similar to list, but with a few key differences. Now this is how we define a dictionary. Now D equal to string, which is key 1, and then there is, okay, maybe the single quotes are not helping. Let's do double quotes here. Check this. Okay. Okay, let's try running it. Invalid character in identifier. Not be that way. Okay. Okay, let's redo this. Okay, so now when we come to
Okay, so now when we come to keys, this will be the introduction for dictionaries. Uh, Dictionaries are very much simple to, very much similar to strings, but a few differences. Now, let's just say we have D, which is going to be a dictionary, and in that we are going to have the first element, then colon 1, then we are just going to remove the spaces and see, right? So we are going to define it, right? So now what happens, what is the key difference in lists and dictionaries is, now you can access a list item by its index. Now 0 at index 0 is 5, but now in dictionaries you can search for 1 by using key 1. You can just say what is at key 2, right? So even this could be, let's just say like rank of Sachi. So now when you run that, you can just say ki, what is rank of Sachi, and it will return 1, right? So you can do a lot of things. You can have different keys. Based upon that key, you can have that particular uh, value. Like how do you have in dictionaries? Like you have words, and for every key there'll be some value, right? So let's try running an example here. Okay, and okay, I'm trying to copy this and paste it here. Okay, now we have a new dictionary which was used, which was defined by the curly braces. Now we have puffin 104, sloth 105, python at 106. Now what we are trying to do is we are trying to print the resident. Now who's residing at puffin, or where puffin is residing. Now if you try to run it, it will give you 104. You do not have to say 0 or 1 or 2. You can say where is slot residing. You can say it will come, it will give you 105. So this is the use of key in dictionaries. And so we'll see how do we do new entries in dictionaries, right? So let's just say we are having a menu and we have defined it like as empty. Now there are flower brackets, says empty. Now we say menu, and we have given the key equal to 14.50. So now in the dictionary menu we have added chicken, which is equal to 14.50. Now let's try to print menu of what is the price of chicken, right? So now if we try to print it, okay, let's comment the other things and also print menu. Now you can see the price of chicken was 14.5, and if we just print the whole menu, it says chicken 14.5. Now let's add the other items to the menu. Menu of soup equal to 6.50, egg 2.50, snack 1.50, right? So now we have, the menu has 4 items, and each item has its key and value. Now let's try to run it. Okay, now in the menu, what do we have? We have chicken, soup, egg, and snack, and these are the respective prices. Now if at all tomorrow I just want only the price of egg, I can just go and print it here, say what is the price of egg, right? So we are just going to get the price of egg as 2.50. So this comes very handy while we use it. So now how do you add a new entry is just by adding opening up square brackets, entering the key there and value, so that you create a new entry in that particular dictionary. Deleting from dictionary, we have multiple ways to do that. So first, what we try to do is use the word del to delete, right? So we have this new dictionary, zoo animals, and zoo animals. Now you can see that the flower bracket is open. The zebra is on the left, on the tiger is on the right, elephant, so and so, dolphin, and peacock. Now what we are trying to do, we are trying to delete the item tiger from here, right? So before deleting, let's try to print zoo animals. Then after deleting, let's try to print zoo animals. Now you can see in the first list, tiger was at the right, and now it is no more there, right? So this is how you delete from a dictionary, by using the del. Now how do you remove more things? Like if you want to remove more things, what you can do is you can, like how we have used dot append and index for strings, we have dot remove here. So you can directly remove. You don't have to know the index, like where is to what. You can directly use remove dot remove and give to what, and it will give you that particular new dictionary, right? Okay, so there was an error. So this was the list, right? The list is there. Now in print, this is how collab works. It's going to run it, right? Stuart is no more there, right? You do not have to know the index of Stuart, right? Now the same way, if you want to remove anything, you can just I write the name of the list and write dot remove and remove whatever you want to remove from that particular list, right? So now mixed dictionaries is nothing but, in a dictionary you can have different variables, right? So for example, now you can see, okay, let's run with a live or bigger example to be clear. Now we have a new dictionary with the flower braces. There is one key which is gold. Now gold says 500. There is another key pouch. It is a list. Now a dictionary has one item which is an integer, the second item which is a list, and third item is also another list. Okay. So now a dictionary can have strings, integers, and many other things. So this can be mixed, right? So now what we are trying to do is, in the dictionary, you can see that we are adding a new key, which is burlap bag, and that new key is holding a list again, right? So let us try to print it here. I'm just going to print what is there in our inventory. Okay, before we add anything, let's try to print it. We have a gold pouch, and the pouch has so and so items, and we have backpack, and the backpack has so and so items in it, right? So now what we are trying to do, we are trying to add okay, let's remove it from here, and we have also added another bag, which is the burlap bag. Let's try to run and see that. Now see, we have in our inventory, there are two bags. One is the backpack and the second one is the burlap bag, and it has apple, ruby, and three-toed sloth in that particular list. Now what we are trying to do is inventory, the key pouch, wherever we have pouch, we are asking it to sort. Now within the dictionary, there is a key which is holding a list.
Now we want to sort that. You can use this dot sort parentheses function to sort it. Now if we try to print it here, you can see. Now let's first show the current pouch. The current pouch has flint twin gemstone. When I'm trying to run it after sorting the pouch, it has flint gemstone twin. Okay, I don't know how to spell, pronounce that. Now what we are going to do is inventory of pocket, new additions. These are new additions. There is pocket is a list. Now we are going to sort backpack. Now we are going to dot remove dagger from this particular backpack, and then for two in the gold we are going to add plus 50, right? So if you see the gold is 50, it is going to become 550. The pouch will remain like that. The backpack will have the dagger gone. The burlap bag is going to remain same, and the backpack will also get sorted, right? So let's try to run it. So it's like mixed dictionaries, and you can do a lot of functions. So okay, let us also print the inventory, right? Now gold became 550, and it is sorted. Backpack is now sorted. Bedroll, bread loaf, xylophone, burlap bag is as it is. Now pocket, in the pocket there's a new addition. Pocket also got added here, right? So now dictionaries, though it is like can have an exhaustive items in that, but it is very useful when we are working with functions and lists. So this brings us to the conclusion of this particular session. And in today's session, we have progressed a little more in our Python learning journey. In our next session, we will see how to use a few functions on lists and dictionaries. The link to the free Python email course, the code snippets, and notes for today's session are in the description. If you like this video, please drop the top 3 comments in the drop top 3 learnings in the comment section, and do subscribe to the channel. Thank you. Hello, welcome to Pixeltest. We are on a mission to upskill 1 million AI scientists and Web3 engineers. My name is Sabyasachi, and let's get started with Python in 10-minute series. In this session, we are going to learn about loops. And in that loops, we are going to first cover while loop, simple errors, what are infinite loops, and while else, right? So let's see actually what are loops. Now, if you have seen any other statements earlier, the if statements and all, they run only when the condition is true. But if at all you want the condition to be checked in a loop, in a sequence, then you require loops. So what we're going to do is we are just going to run it once in our collab. Okay, so what we have done here is we have set count equal to 1. This will show us the difference between if and while. Okay, so the first statement, if count is less than 5, then it's going to print the count. While in the while statement, this is called the condition, right? So now while count is less than 5, print I am a while and count is this. Now then what we are doing is count is equal to count plus 1. So we are incrementing the count by 1 every time the loop is going to run. So let's try to run it. Now you can see that the if statement ran only once, but the while statement first ran when it was 0. 0 is less than 5. Then it printed 0, 1, 2, 3, 4. And then when 5 is less than 5, when that incremental happened, and when the condition was 5 is less than 5, it was false, then it broke the loop. That is how the difference, that is what is the difference between if and while, right? So now it's very important to remember that we have to always either increment or decrement count, or else what happens is we get into a situation which we'll see is called as infinite loop, right? So now what we are doing here is number, we are initializing it to 1 while number is less than or equal to 10, right? What we are trying to do here is print the square of that particular number, and then we are incrementing number by 1. So it will run until it is 10. So it is 10 bar 2, it will run till then, and then it will exit, right? So you can see 1 square, 2 square, 3 square till 10, right? So we'll use while loops also in our code, and a few common errors that people normally do are like a few common errors that people do can be checked by using while loops, right? So let's go ahead and try running this code. Now what we're trying to do here is we are asking the input from the user by using the function input function. Now then in while, what we are trying to do is we are checking while choice is not equal to y and choice not equal to n, then input, then what we are saying is, sorry, I didn't catch that, enter again. So that we are taking in an input. So if it is y or n, this will end, the while loop will end. If it is anything else, it is going to say, sorry, I didn't catch that. So now what happens is you can check for a few errors by using loops. Now this is the first time you're using input function. This is an inbuilt function, and now you can see that whatever statement the string was there between the parentheses comes as a question, and then you have a field to enter some string or variable or integer, and that gets saved into choice, right? So now I'm saying enjoying the course, let's just say I'm saying 7, right? So then it says it is not y, it is not n. So then it says, sorry, I didn't catch that, enter again, and that is also in an input. So it will do that until you give it a y or n. So when you give it y, it will end, right? Because you have not written any other statement after that, right? So you can use this for eliminating or checking for a few simple errors. Now infinite loop is a situation where you have given a code. We're not going to run this code, but I'm going to show you. Now count is equal to 10. We have initialized the variable count to 10. Now while count is greater than 0, count plus equal to 1. So we are going to increment it. So now what is happening here is we should have actually decremented it, like decreased it, and then 0 is greater than equal to 0, and then it will end. Now it will keep on increasing, and the count will always be greater than 0. So this loop will keep on running, and this will take your RAM and disk RAM, and it will crash your program. So infinite loops are risky, and they just zap you off your RAM, right? So what other things we can do is we can use break statements. So now what are break statements? In break statements, whatever whenever the condition is false, then the loop breaks, right? So let's just say count is equal to 0, while there could be any statement, like it could be 1 equal to 1 or any true statement. We are going to do we have it here. Let's have it like true, print count, right? Count plus equal to 1, right? So it will keep on printing whatever count is current count is, and if count is greater than or equal to 10, then it will break, right? So after that this program will not run. So one way to stop your program from not continuously looping is use break statements on some condition where you want the loop to break, right? So these are break statements. And then we also have the while else loops. If you look at while else, they are very much similar to if else, but only thing is uh, the else runs only when the condition is false, right? So now if you look at this particular piece of code, you can see that import random. So we have imported the module random. Now we have printed lucky numbers. 3 numbers will be generated. If one of them is 5, you lose. Like this is like a game playing. We're playing with the computer. Right now, count is equal to 0, while count is less than 3. So this is going to run how many times? 0, 1, 2. Right? It's going to run 3 times. Now number, there's a variable. There we are saving the random dot randint. Now this is the function in the random module. So random dot randint 1 to 6. This is taking 2 arguments. So it is going to generate random numbers from 1 to 5, right? So now print number. So it is going to print whatever number was there, going to print it. Now if number equal to 5, which means if number is equal to 5, print sorry you lose, because the program says if one of them, three random numbers will be generated because it is going to run 3 times, and if one of them is 5, then you lose, like you're going to lose, right? System wins, right? Then only when after you lose, the game ends and then we break. But now if it is not happening, it will not break and increment the counter, right? So it will increment. Now else, meaning whenever this becomes false, like when 3 is less than or equal to 3 and becomes false, and in that fourth execution itself, it will run the else statement. So the else runs only when the condition becomes false. Then print you win, right? So let us try to run this. Okay, lucky numbers, 3 numbers got generated. If one of them is 5, you lose. The numbers generated were 6, 1, 4. So we won, right? Now let's run again. We did not get 5 was not generated. Yeah, so now what happened on the first iteration itself, 5 was generated and we lost, right? So this is how this runs, and we can also make some interesting loops using this, right? Now what we are trying to do is the same statement, we'll try to make it into a guessing game. Now what we are trying to do here is, from random we just imported directly the randint function, right? So we don't have to write random dot randint. Now we are trying to generate a number from 1 through 10, right? So we have been generating 1, 10. Guesses left is 3, so you get 3 guesses, right? Now what happens is this random number is going to save something from 1 to 10 that we don't know yet because we're not printing anywhere. Now the game starts while guesses left is greater than 0. So you get 3 chances. Now guess is a variable is equal to int of input your guess. So input will call the will ask us for our input by giving a field, and that is getting converted into an integer. This whole of it is getting saved in the variable guess. Now for example, I have guessed 6, guess is 6, right? If 6 equal to random number, if guess is equal to random number, then print you win. right? Because I guess the game. Yeah, guess the number. This is the guess game. Now, then you win, and then it breaks. Now, guesses left is going to be decremented, minus equal to 1. So it is going to be 2. Then it is going to be 1, and then it's going to be 0, and then this condition becomes false, right? And when condition becomes false, it says you lose. So you were not able to guess a number between 1 to 10, which was actually selected by the system, right? So let's try to run it. Okay, so it's asking me the guess. So I say, let me guess, the number could be 9, and I enter. So it was wrong. So let me guess it again. I'm going to enter 5. I'm going to guess, enter 1. I lost, right? So, this is like a game that you can play. Let's try to see if 4 is not the number, 2, then 3, lost, right? So basically we could go on forever, but then yeah, so you'll there's a chance where you guess the game, guess the number, and win the game, right? So this was while else, and this brings us to the conclusion of this particular session. In today's session, we have progressed a little more in our Python learning journey. In our next session, we will see a little more about loops, how to work with for loops, and the link to the free Python email course, the code snippets, and notes for today's session are in the description. If you like this video, please drop the top 3 learning in the comment section, and do subscribe to the channel. Thank you. Hello, welcome to Pixeltest. We are on a mission to upskill 1 million AI scientists and Web3 engineers. My name is Sabir Sachi, and let's get started with Python in 10-minute series. So in this series, we are going to learn about loops, continue learning about loops. And what we are going to see is for loops, for else loop, looping over dictionaries, enumerate, and multi-lists, right? So let's get started with for loops. So for loops are very much like while, but they have a little simpler notation and widely used over while loop. So now if you see, we are going to print counting, means just a indicator. Then what we are doing is the notation works like this: for I is going to be the variable in which from the range of 20. So now range of 20 is going to generate numerics from 0 or 1 till 20, right? So then we'll start printing I, right? So right now let's put it in braces, now parentheses. Now you see the range started counting from 0 till 19. So 20 was not inclusive, right? So now you see while had a little bigger or a little complex conditioning. We have different use cases for while and for, but you can see that this was a little easier. So now let's also see how we can use for loops with lists. Now this was directly with integers. Now we say we have defined hobbies as a list by giving empty square brackets. Now what we have done here is for num in range 3, right? So now if you look at range from here, so it's going to be 0, 1, 2. So num will be 0, 1, 2. Then the for loop definition starts hobby, a variable that's getting defined, is equal to input. So it is the computer is going to ask us, tell me one of your favorite hobbies, right? And whatever we enter is going to get saved in hobby variable. Now the list hobbies dot append. We have used dot append function earlier also while we were studying lists. Now the hobby, whatever was entered, gets appended and added to that particular list. Now this will run for 3 times, and then the whole list gets printed, right? So let's try running this. So tell me one of your favorite hobbies. Let's just say I'm saying cricket. Run again. Let's just say yoga. Let's just say Netflix. Okay. What happens is now it is going to print the list hobbies, whatever we have entered. Now, this was a very simple way to use loops with lists, right? So similarly, we'll also use the for loop with strings, right? Let's just say we have defined a string, which is caret with exclamation. For C is a character in thing, right? Now print C, okay? So this will go, character by character and start printing C, the each character. Then there is another word which is X, which is also another string, right? So now for character in word, which is nothing but the same thing, you're just going to print it, right? So with strings, you can always use for loops also for trying to get each if you want to run a function where you want to check what is each of the character, and if you want to check if there is one specific character, you can do a lot with conditions in the for loop also, right? So now we've understood what is for loops, and now let us see what is for else, which is very much similar like while else. Only when the condition is false, you will run into the else statement, right? Now fruits is a list with you say there are 5 fruits in that. Now we are trying to say print you have for f in fruits. Now f will have banana first, orange, pear, and so on, right? If f is equal to tomato, which means if it is, this is like a check, right? F is equal to tomato, print a tomato is not a fruit, right? Okay. Now then break, right? Because it's no more a fruit and then it's breaking. Else, if as long as it's not tomato, print a comma f. Now f is going to be the fruit. Now it's a banana, a orange, so and so, right? And whenever this is false, if whenever we run whenever we see that it's not breaking, then the else will run, will execute when the condition is false or when it is ended, right? Print a fine selection of fruits, right? So let's try to run it now. Okay, so this is how collab works, right? Now you have a banana, a orange, a pear, and then tomato, f was tomato, and tomato became equal to tomato and said a tomato is not a fruit, right? So let's see what happens if we remove the tomato, right? Now when it was a tomato, it broke, right? Because the break statement was there and broke out of the loop and came out, right? It stopped running. Now let's just say it hits the end of that particular list, then it will run into the else statement, right? You have a banana, a orange, a pear, a grape, a fine selection of fruits, right? So this will run when the condition is false or when the list reaches its end, right? So a few notes. What happens is if we put up a comma towards the print statement, right? Sorry. Now word is marble. For each character in word, print each character. But right now what we have added additionally is a comma, which means print each character after in the same line, right? Okay, so let's try confirming it. Let's try run. What was the error? Okay, I think the comma is out of the print statement. Huh? Okay. Okay, am I missing something? Print in identifier. Okay. Okay. There's to be some, maybe is it the indentation? Okay, just replace the indentation with a tab. Okay, you know it. So everything was running well, everything was good, but I just replaced the spaces with a tab. Now it's marble. Now I'm just going to add a comma in the character. Okay, so let's try to add the comma afterwards and see. It did not help, right? So now this is how you use this for loop, right? So this whole note is going to get trimmed, right? Okay, now let us try to run this. Okay, so we're good. So let's move on. Looping over a dictionary. Now let's check this code. We are going to add it here. Now we have defined a dictionary, open the flower brackets and said for the key X, 9, Y, 10, Z, 20. For key in dictionary, so these are the keys. If the D of key, which means the dictionary first key, if it is X, now dictionary of X equal to 10, whenever it is equal to 10, print this dictionary has the value 10, right? So basically we are kind of doing a search, right? So let's just try replacing the print statement with tab. There could be an indentation issue. Okay, so yeah, we're good. Let's try to run it. Now the dictionary has a value 10, right? So you have used a for loop in a dictionary and got it working, right? And enumerate and multi lists. Okay, so now many times what happens is we would want to also have the number, the index of the loop, right? So let me just show you both. What is the difference between a regular for loop call and an enumerate for loop call, right? So let's just fix the text. Okay, so first we are going to run the regular for loop. Now we have a list which says choices: pizza, pasta, salad, nachos. Print your choices are. For item in choices, when it is pizza, print pizza. When it's pasta, print pasta. So we are going to run it. So now you see that your choices are pizza, pasta, salad, nachos. Now when we use something called enumerated for loops, what we do is for index comma item. So this is how it works. Normally it is the item, but in enumerated list you also can get the index, right? In enumerate you have to use the function enumerate and pass the list into this function, right? So here it is regular choices, here it is enumerate choices, here it is just item, here it is index comma item, right? So now what you can do is directly print index comma item, right? So your first choices are pasta, pizza, salad and nachos. Your enumerated choices are 0 pasta, 1 pasta, 0 pizza, 1 pasta, 2 salad, 3 nachos. So enumerated helps you in also getting the index without having to use additional lines of code. You can directly start initializing that variable to have the index in the loop itself, right? So that is about enumerated loop. Now we'll see what is multiple lists. So many times what happens is you might want to compare two lists parallelly, like one for one, like the first row of this list and first of this other list, right? So that is why we have a function called zip. Now this will combine two lists, two or more lists also. Now what it's going to do is for a comma b. So now a will have 3 and b will have 2. Now in zip, lists a comma list b, so we are going to use it, right? It is similar for items in range. It is similar for a comma b in both the lists, right? Now we are going to print max of a comma b. So now you can check, compare both and see what is max of them. And whenever you hit the smallest list, like when that ends, the comparison also ends, right? So out of 3 and 2, 3 is max, 9 and 4, 9 is max, 17 and 8, 17 is max, 15 and 10, 15 is max, 19 and 30, 30 is max, right? So zip is something that helps you to compare while using strings, multiple lists, right? So this brings us to the conclusion of the session, right? And in today's session, we have progressed a little more in our Python learning journey. In our next session, we will see how to work with classes, and the link to the free Python email course and the code snippets plus the notes for today's session are in the description. If you like this video, please drop the top 3 learnings in the comment section and do subscribe to the channel. Thank you. Hello, welcome to Pixeltest. We are on a mission to upskill 1 million AI scientists and Web3 engineers. My name is Sabyasachi, and let's get started with Python in 10-minute series. In this series, we are going to learn about classes. What are classes? Why do we use them? What is the syntax of it? A simple real-world example. What is inheritance? And will be more practice, right? So we'll start with why classes. We will use more of practice because it's more of a hands-on topic, right? So to understand classes, we need to understand objects. So we create objects out of classes, right? For example, there is an animal class, then dog is an object of that particular class, right? And this dog has a few attributes that are defined in the class, right? The height, color, breed, and example. That's how. And there are functions like bark and all those things. So whenever you create a Pomerian, which is a new object of that particular class, it will have the function bark. So every dog will have that particular function. So now these functions are called methods. Now let us see in action how do we use and create these classes and objects, right? So the class has primarily the first portion, which is the class definition. Like let's just say class, the name of the class, which is animal here, and in the parentheses we have object, right? Now if you see the first method that we use or create is define is init, right? So init, so which is a short for initializing. Now definition of underscore underscore init underscore underscore, right? So this is how you write it. And then in parentheses there is the first parameter is called self. So why do we have the first parameter as self is we refer to the own object that is getting created, right? For example, we are creating the animal dog. So now that particular object dog.name is equal to the next parameter that is passed, name, comma, age, right? So now what we are going to do here is self.name equal to name, self.age equal to age, right? So only while defining you need to add the self parameter, but when you're passing an argument you can just have name and age, right? So let us try to see how do we use it. Okay, now if you see, we have created an object called zebra and we have given it the same attributes, name and age. Now we have called the class animal and passed on the initialization parameters, right? So whenever we create a new object, the first method to run is the initialization, right? So now here this object got initialized and it got these attributes. So now what we are trying to do is try to print these particular attributes, right? So let's print it. Now the zebra.name is Jeffrey and zebra.age is 2, right? Now, for example, by initializing only, we want to give another parameter or the attribute in real life is hungry. We want to know if the animal is hungry. So we say self dot is hungry equal to, whatever parameter is being passed is hungry. Sorry, hungry, right? So now that is done. Now you can say it is true or false, right? So we want to print zebra dot is hungry, right? So let's try to print it. Now it says yes, it is hungry, true, right? So this is the definition. This is how you create an object. This is how you print the attributes of the object, which is something that we have been doing from the beginning, right? So now let us try to understand what is scope. So if you look at scope, whenever we are dealing with classes, we have variables that are available everywhere. These are called global variables that are available only to the members of a certain class. These are called member variables, and variables that are only available to a particular object or instance is called instance variable, right? So now let us just try to add in a line here. It says is alive true. Now if you see, this attribute is being already given before we initialize the object itself, which means that this is available for all the members. So is alive is true for all the members by default, right? So now even if I try to call zebra dot is alive, should say true, right? So now what this means is this is in a scope that is available for everyone, and this which is more of a member variable, right? So that is class scope. We'll see more of it in detail going forward. Now let us see a real world in a use case. Now we don't have animals and flowers only while working in real world scenario. Now if you look at the class that is being created here is shopping cart, right? Now the shopping cart function, what they have done is they have initialized items in cart to be empty, right? Now this is the class variable. Then whenever an object is created for the shopping cart, what is initialized is the customer name, the self dot customer name is equal to the customer name that is being passed, right? So for example, if you are passing one, if you are initializing a new object, it will have the customer name passed on in it, right? So now add now what this was the attributes that were given. So let us keep it simple. Now what happened is there is another definition of a method apart from the init method. Now how init is defined is there is underscore underscore init underscore underscore, and within parentheses you have your parameters. Now general definition of function is as usual we do, but the first parameter is always going to be self, right? So now while you're initializing, while you're defining the function, you just need to have the parameter self, but while passing on the argument, you need not have to have 3 arguments. You can just have product and price. Now what we are trying to do in add item is we are going to check if the item is there in cart. If it is there in cart, we are going to say the product is already in the cart. If it is not there, we say the product is added, right? So the function here is if not product, I mean if the product is not there in items in cart, self dot items in cart, then items in cart of product is equal to price. So the price gets added to this particular items in cart, right? So print product is added, product added, right? So let's say we are trying to initialize say user equal to shopping cart, and we have to pass the customer name. Let's the customer name be Ram. Okay, so we have passed in the name of the customer. Let's try to print it. Now let's try to run it. What is the issue? Okay, let's say okay. Okay, this is how collab works. We keep forgetting we have to have parentheses in all our print statements, right? Okay, so we are going to run it. Okay, so now the user got created. Let's try to see user dot customer name, right? So let's try to print user dot customer name. That should print now, right? So now user is an object of shopping cart, right? Now the initialization is done. Now what we can do is we can add an item to this particular function. So how do we do that? User dot add item, and we are going to, the product is, let's just say earphones, and the price is 15. Okay, now we are trying to run it. Okay, so now the earphones got added, right? So now what we are trying to do is let's try add another earphones which is of price 25 and see what is happening. Earphones is already in cart, right? So now this is the same way you can create another user of the same shopping cart class and try to add or remove items by writing functions, right? Okay, so this is how we use it in real world. If you look at inheritance, this is an important topic of classes. Now, let's first try to run with the code and understand, right? So many times what happens is we inherit from a parent class, right? So now if you see, there is a class which is shape, right? Now in that we have, whenever we create, the initialization takes number of sides. Any shape has sides. Now self dot number of sides is the number of sides passed, right? So this is like a parent class. Now we have another class which is like a child of this particular class. Now that class triangle, instead of object, we pass the class from which we want to inherit a few properties. Now if you see, when we have passed in the shape, the number of sides function is also, the number of sides attribute is also passed on into the triangle, right? Apart from that, it is also having a initialization of its own, which has the length of side 1, side 2 and side 3, right? So this is inheritance. What this triangle has done is inherited shape. So you can have another analogy where there is a vehicle, and there could be a class which says tractor and another which says a four-wheeler, right? So both of them are vehicles, but they have properties like number of wheels and all, but they are not same, right? So some properties which are common for all vehicles can be inherited by the child classes, right? So so in a way, triangle will also have the number of sides. That is what inheritance means. We'll see this in a little example in our practice. In this series, we are going to learn about classes. Now, what we'll try to do is try to understand the classes in detail by practicing a little. Now if you see, there is this first class which is triangle, and number of sides is 3. So all triangles are going to have now sides as 3. So now this is a class member variable, right? It is default for all of the objects that get created. Now whenever a new object gets created, what is initialized? Angle 1, angle 2 and angle 3, right? So whatever is passed in the parameter as an argument, that is given as an attribute for that particular object. Now what we are trying to do next is we are trying to define another method apart from the initialization, where we only have the self parameter, which is just going to be the object. Okay, now what we are going to do here is check angles. Now the sum of all the angles in a triangle should be 180. So that is what we are going to check. Then only it is going to be a triangle. So we are going to return true if it is equal to 180, false if it is not. Okay, so we are going to say define check angles pass self if self of angle 1 plus self of angle 2 self dot angle 3 is equal to 180, return true, else return false, right? So this is a method. Now we have another class which is equilateral, which is inheriting the properties of a triangle, which means, and here it also has its own class member variable, which is 60, because in all of the angles of an equilateral triangle is 60, right? So when we are initializing an object of equilateral, or the angle 1, angle 2 and angle 3 are going to be the angle which is 60, right? So this is how this works. what we are trying to do right now is yeah, so this is a little about inheritance in detail. Okay, now let us look at a few more examples where we initialize the objects also. Now we have a class which is car and the condition is new, right? So this is the class member variable which is default for all of the objects. Now when we initialize, there are three variables that are getting added as attributes, which is model, color, and mpg. Now these are member variables. The objects are going to have these particular attributes. Okay, now here init is initializing a class, and now my car equal to car and passing on the variables model, color, and mpg. Now this DeLorean is the model, silver is the color, 88 is the mpg. Now this is the instance or object, right? Now we are trying to print my car dot model, which is this particular member variable, and my car dot color, my car dot mpg are member variables. My car dot condition is calling the class member variables, so which is this one. So if we try to do something similar here, my triangle equal to, what we are trying to do here is triangle of the object name we are going to pass as my triangle. Okay, so we have passed it on. Okay, we are okay. So we are passing my triangle equal to triangle, and in parentheses we have angle 1, angle 2, angle 3 to be passed. So we are going to pass 30, 60, and 90, right? So what are we trying to do here is, okay, sorry, the spelling is triangle, right? So now I'm just going to run it. So this is the same way. So the object will get created, my triangle. Now I'm going to print my triangle dot angle 1, which will be 30, and I'm going to print my triangle dot number of sides, right? So if I run it, you can see that the first angle is 30 and the number of sides is 3, right? So the same way here also you are going to get the respective values, right? Now class methods is the way we have created these. These are the class methods. You can see check angle, right? So now if we want to check this, it is my triangle dot check underscore angles, right? So okay, so this is there. Now let us try to print it. Okay, and braces, parentheses, never forget that. Just true, right? So the sum of them is true. Now this particular method
is the class method, right? Now, if you look at, okay, let's make a note of it. This is class method. Okay. Now, if you look at a little in detail here also, we don't have to run it. Car object was created and the condition is new, and there are 3 attributes that are passed like we have seen. Now there are class methods that are written: display car and drive car, right? So let us try to add them here. Display car and the drive car, right? So print function needs parentheses. Okay. Now what we are going here is there is another car object, another class electric car, which is inheriting the actual car, right? So whatever condition it will have, the electric car will also will have, right? The model, color and MPG are already there, and there is a new parameter or attribute being added, which is battery type, right? So here also we have our own drive car method, though it is already there in the parent class. This particular function method is overriding whatever was there in the drive car here, right? So it will say it earlier, if we are driving the car, it used to say used, here used but still new, right? So we are modifying the member variables by writing functions in the inherited class that we have created, right? So now if you see my car equal to electric car, and we have created this new object my car, which is an object of the inherited class, right? We have passed on the 4 attributes here. So now we are trying to print my car condition, then we drive the car, and then we check the condition again, right? So let us try to run this. Okay, we'll try to run this freshly here. Okay, no changes. Okay, so let's do this. Okay, let us try to first print my car condition. Right, so the my car condition, the electric car's condition is new, right? So then what we are trying to do, we are going to drive the car. Okay, so we have driven the car. Now we'll check the my car condition. Now what happened is, in general, if you see the condition drive car function should actually just say used, but it is saying used but still new, because we have overridden the method that is there in the parent class, right? So this is going to be the modifying member variables or methods, right? Now a little now a little now we'll also see how to make our function initialization beautiful, right? Sometimes, yeah. So now building useful classes means now we have seen that whenever we print any particular class, it comes in a particular format, right? So this is called the representation. Now there is a specific method which is underscore underscore repr underscore underscore. Now this is short for representation.
And how does this work is, we will create a class point 3D, and there is object as the parameter. Now when it is initialized, we are passing on the parameters x, y, z, and self dot x equal to x, self dot y equal to y, self dot z equal to z. Now the object gets initialized, and then there is another function which is repr. What happens here is, like the functions where we are directly passing on self, we are going to pass on self, and it is going to represent %d. So there is a print statement. Whenever you are running a print statement, this is how it is formatted, right? So the placeholder %d will have self.x, self.y, and self.z, right? So now we have created a new object, my point equal to point 3d 1, 2, 3. Now when you print my point, it will print in the format if it is defined wherever there is a representation function. If we do not have the representation function, it will not print or print in a different format. So let's try to comment this, try to print. Now you see it has printed in a format that we don't understand, right? Or which is as good as not printed. Okay. So indentation is very important. Now, whenever you're printing something, having a function repr is going to be helpful to format the object prints better. Now, having a repr function will help you to format your objects and functions better. So in this session, we are going to learn about files, how to input, how to read and write to and from files, what is file input and output. So this is a very short and easy to understand section. So we can directly try to run the program and understand. Now, till now, what we were doing is my list. Like, let's just say if there's a list and we are trying to print it to console, right? My underscore list, right? But what if we want to save it to a file, right? So now this is what it got printed, right? So now what we are trying to do here is, let's do a few more lines of code. Okay. Now what we first do is, we have created a file object. F is equal to open, then the name of the file, output.txt, comma, the mode. W means write mode, R means read mode, right? So doing this will open the file in write mode and prepares Python to send data to the file, right? So this is the opening. Now for item in my list, now for every item, when item is 1, item is 2, f dot write string of item. So what we are doing is, in the file object that we created, we are writing string, we are writing the item, converting it to a string and writing that particular item, and also adding a new line statement to new line, so that every particular item comes on a new line, right? So write some data to the .txt file. Now this for loop will run until we reach the end of the list, and then f dot close. Now this closing is very important. If you do not close, the file will not get saved properly, right? So now output.txt is the thing, is the file where this all will get saved. Okay. So now because we are running in Colab environment, you can see that this got saved to your drive. Now if you click this, you can download it. Okay, once you download, you can either open it in a text reader or you can open it in your browser. Now you can see that whatever we were writing to console got written out in this text file with the /n, which is the new line character, right? So this is how we write to a particular file. Okay, so now what we are going to do is we are trying to read from the file. Okay, so let's try to remove this for now, and we are going to open the file in read mode, and then we are going to print whatever is being read from the file to console, and then close the file again, right? So let me, whatever I've pasted, let me try commenting it. Okay, let's try to remove this particular additional lines. These are lines, and try to run. Okay, so whatever was there in the file was read and printed onto the console. Now let us comment the list also. So you might think that it's getting printed from here, but if you see, it is picking up the data from the file and reading out to the console, right? So now what if at all we want to just read one line at a time, then we have the method dot read line instead of dot read. Okay, so let's try to comment these also, and we are going to open it in read mode again, and try to print it to console, right? So now only one got printed. Okay, so if at all you want to print more lines, you can just go ahead and say print another line, right? So it printed the second line, right? So in the same way, you can print multiple lines line by line if at all you want to read one after the other, right? So this is the read line method, and many times if the file is not closed, you run into errors. So for that, we use this method f.closed to check if the file is closed or not. Check if file is closed. Okay. Now, okay, let's try to run it. Okay. It says it is true. Let's just say if it is not closed, then what you can do is if it is not closed, then we are writing a function. If f.closed if it is not closed, then go ahead and f.close. So you can always try to use this function to use this statement to close the files. So you can use this statement to close your files, right? So this was something quick about file input and output. In today's session, we have progressed a little more in our Python learning journey. In fact, this is our last essential lesson for Python. So the link to the free email course, the code snippets, and notes for today's session are in the description. Right? If you like this video, please drop the top 3 learnings in the comment section and do subscribe to the channel. Thank you.